So for today, it is called applications of exponential functions. So that means you have like word problems. So we'll give you a chance to model. No, not like for Calvin Klein, but to set up an equation to model a situation. All right. So Rita wants to invest 500. Ooh, this sounds like a starting value to me. Y equals 500. Do you remember these? Its doubling time will be 8 years. Ooh, what the heck does that mean? Doubling time. It's going to double. Would you agree that that's like timesing by 2? 8 years. Do I put an 8 here? That doesn't seem right. That's going to make it way more than double. I did talk about these one day. Does anybody remember? Yes. X over 8. You are correct. What annual percentage rate is necessary for this to happen if the interest is compounded annually? Oh, boy. Okay, then they just changed the problem on me. Your way would have worked. That's a really good way. But they want us to solve for what rate it was. If they want me to solve for the rate, then I'm going to have to put that kind of formula in here. 1 plus the rate, and that's going to be my variable. Do you get what I'm saying? Do you remember this kind? 1 plus the rate? And remember, if it was monthly, it would be divided by 12, but it's not monthly, so we're not going to do that. Okay. And then what should I do with the 8 in this situation? It does go up here. Do you get that the other way couldn't let you solve for the rate, but this way I've got an R where the rate is supposed to be? All right, now there's one more little twist to this problem that a ton of people don't see. Right now, I got 2 variables. I can't really solve it, but I know one of those variables. Yes, because it says it's going to double. You know that means it's going to end at 1,000. You got to put the 1,000 somewhere, right? If it's going to double, 500 turns to 1,000, so you put the 1,000 here. Now you could solve this thing. Everybody get this started, and I will help you start solving it. Who knows the first step? You won't need a calculator for a long time. What's the first step? Divided by 500. Why? Because you want to get the R alone. And then dividing by 500 gets that pesky 500 off of there. And then 1,000 divided by 500 is 2. Well, gee, I could have just done that right off the bat. But nobody would have known to set it up this way. Okay, now what? This is the part where the calculator would be handy. Because you're going to put it to the power of what? 1/8. Remember that if you type 2 to the power of 1 divided by 8, your calculator will say, sure, I'll take 2 to the first, and then I'll divide it by 8, because powers go first. If you want 2 to the 1/8, put the 1/8 in parentheses. That'll make sure you actually do 2 to the 1/8 instead of 2 to the 1, and then divide by 8. From here, if you can't solve this, it's probably because you don't know how to use your calculator. So take a second, use the calculator. You can use your iPad's calculator if you need to. Leo, what'd you get for the 2 to the 1/8 part?
1.09.
Awesome. Equals 1 plus R. And then don't I just want to take away 1? And that kind of makes sense, doesn't it? 0.09 is the rate. Raise your hand if you had that one right. Cool. All right. Now, I doubt many of you, without a little bit of pushing, would have figured out this equation. But now that you see that equation, where you have the starting value here, the rate here, the time here, let's see if you can do this next one. Remember, you got the end is usually the y. And then it equals the start. And then 1 plus the rate to the x. End is the thing on the way left. The start value goes right in front of the parentheses. You always have 1 plus a rate, unless it's shrinking. Zeke, what's the start value? In this problem? In this problem, what's the start value? It's like a price. So you got to look and see which came first, because whichever came first, that's the start value. Zeke, do you see the January 2000 price? There we go. I didn't ever say anything. You just assumed you must be wrong and you changed your answer. Okay, so start was 1.31. Then, by January 2007, that's the end of our little experiment, 3.15. And then 1 plus the rate, which they never told me the rate, because I got to figure it out, to the x, but I know how long that time that was. Did you guys use 7? All right. Because 2001 was 1 year, 2002, 2003, 2004, 2005, 2006, 2007. It is 7. All right. So then this is to the 7th. And there's my actual equation. You're going to be doing some nasty decimal dividing and then put it to the power of 1/7 and all that, and then get the answer and then compare with the kid next to you. I'm going to pause for a second. Will you get this figured out? No fair just saying, I don't get this kind. You can ask them for help then. All right, so I would have started 3.15 divided by 1.31. Then I would have put it to the power of 1/7. What is 2.4046 to the power of 1/7? Did you guys get 1.133? Okay. 1 plus r, so then we subtract 1 and we got about 13%. Raise your hand if you had that one right. Okay, awesome. There's another kind of question where they don't expect you to know the formula. They give it to you. And on this kind of question, it's so easy. All you got to do is stick the number they give you in the right place. Like if they give you the height, can you tell where to put it? Maybe it's under the H. If they give you a time, would you know where to put it? Yeah. Okay, so how tall is the average 5-year-old male elephant? Okay, well, 5 must be the number of years, so I'm going to put a 5 there. And then you just multiply it all out and do little cube rooting and stuff. And I know it's a little annoying because where the heck is cube root? I would do to the power of 1/3. 13 times 5 is 85, and then you do it to the power of 1/3. That's what cube root means. And then you'd add 3, and you'd have the height of the elephant. There are some things like this in the real world where they have equations to tell, like, how tall should an elephant be? And usually they are able to use it in reverse because they can say, like, oh, the elephant was this tall. Then we can figure out how old must it have been. You know what I mean? Like they find a dead elephant and they can say, oh, that was a 35-year-old elephant or whatever. All right. What if they give you the 10 feet? Well, then, duh, you're going to put it here instead. All right, let's move on to the next kind. This is the same exact thing. They've given you an equation. They have 2 things you could give you. They could give you the D, the diameter, or H, the height of the tree. Would you please take a second and answer question A? Well, 12's got to go somewhere. Probably goes there, right? And now, pro tip on making your life easier. Times both sides by 3. That's the smart way, everybody. You know why? Because then you don't have fraction in your problem anymore. 12 times 3 is 36 equals 5d to the 0.8. Then I'd divide both sides by 5, and then I'd put it to a power. And I totally get, you might get stuck on the power part. Let's talk about that for a second. How do I get rid of a 0.8 power? I'm going to put it to the power of, don't overcomplicate it, 1 over 0.8. So I don't know exactly what that is, but my calculator will. You know what I mean? Like I'm supposed to use a fraction and do a reciprocal of this. And the calculator will know what 1 over 0.8 is. What is 1 divided by 0.8? Oh, it's 1.25.
1 divided by 0.
1.25. So, and I know those two will cancel each other out. So it's really what is 36 divided by 5? What is 7.2 to the power of 0.125? I got 1.27. Anybody else get the same thing? Yes? Oh, not many people got that. I'm getting nervous. Okay, let's see what I might have messed up. I'm going to go 1. First, I'm going to check that first one. 1 divided by 0.8. Is that really 1.25? It is. Those cancel each other out. Then it's parentheses 36 divided by 5 parentheses to the power of 0.125. Unless you guys are like just racking me up on the fact that it's 0.1279, which technically shouldn't round to 0.127. That's what I'm getting. Raise your hand if you got the same thing. Yay. I think we're right. Now, could I be wrong? Sure, I could be wrong. But let's test my assumptions. Did you start by multiplying by 3 on both sides? And I know some of you are like, yeah, you shouldn't have done that. You can totally do that. I'm timesing by 3 so that it'll cancel this 3. Doink, doink. 12 times 3 is 36. Then you divide by 5 to get rid of the 5. And you put it to the power of 0.125. Yes?
Did you put it to the power of 0.125 or 1.25?
Ooh, excellent question. Is it 0.125 or is it 1.25? Okay, thank you. 1.25, did I hear that correctly now? All right, sorry about that. So, 36 divided by 5, and that to the power of 1.25. How about 11.8? Raise your hand if you would have had 11.8. Now all the hands go up. Okay, at least somebody told me where it was. I had my decimal in the wrong spot. All right, so I'm blaming Siri. If the circumference of the tree is 75, well, then all you do is you stick the 75 in to the other spot. Oh, wait, that was nasty. The circumference is 75. You can't just stick a 75 there. You have to know how circumference and diameter are related. I've found that this is one of the most handy yet unknown formulas. Don't say it. Who knows the formula for circumference? Don't say it. Write it. Write it on your iPad if you know this one. Circumference is what? Not like the distance around a circle. I want the formula for it. Who knew it was pi times the diameter or 2 pi times the radius? Raise your hand if you had one of those two memorized. That's less than half the class. So, moral of the story, you should memorize those. Why? Aren't we just going to give you all the formulas? No, not in honors. And on the ACT tests, they do not give you these kinds of formulas. You either know it or you don't. And on the SAT, if you're terrible at memory, you maybe should take the SAT because the SAT doesn't require you to memorize the formulas. But then again, it's harder in other ways because they're giving you all the formulas, then they make the problems more tricky. So, all right, back to this. If I was going to use my circumference being, what did it say again? Circumference is 75, then I can put the 75 here, and then I could figure out, what do I really want? I want the diameter, right? So I should probably use that top equation for the diameter. And then I could take 75 divided by 3.14. And I get 23.9 diameter, about 23.9. And then I could put that in here. I got 19 for my final answer. Who had 19? Oh boy. Okay. Better double check. So what I got was 23.9. Did you guys agree with that one? 23.9 diameter? Okay. So then I times it by 5 and then divided by 3. That's a way you could do that. 23.9 times by 5. And take that answer and divide it by 3. I get 39.8 approximately for all this part. 39.8 to the power of 0.8. 19. Got 19 again. Now, unless somebody can show me what I'm doing wrong, I think it's 19. It's 5/3 h equals, you know what? I don't want to take too long on this because this isn't even the most important part. So, all you're going to do is take your numbers, stick them into the formula in the right place and solve. Let's get to the most important part. We're only like halfway through this thing. Invest 4,000, 3% quarterly. Do you remember this one? Set up this equation. It's right off our last project. Except it's not monthly, it's quarterly. Please stop obsessing about the last problem. We can talk about that later if you want. I'm sure somebody during work time will figure out what was going on there. I think I had the right answer, but let's get on this one now. You should start with 4,000, and then you go 1 plus the rate, which I know, 0.03. Quarterly means divided by 4. Now, nasty little twist. How much money will he have in 3 years? Do you think I should put 3 up there? No, because that would mean 3/4. And we aren't, 3 years isn't anything like quarters. See, we're in quarters. So how many, 3 years is how many quarters? 12 quarters. It's tricky because in one case they told us to do it quarterly, which is like every 3 months. And in the other case, they used years. They used months here and years here. So then we have to make it the same. So we're going to use months. No, quarters, sorry, quarters. All right, good enough on that one. And now we get to the meat of like, I think you'll have a test question like this. See if you can do this. Remember, it's monthly in this problem. So set up your equation. If you set up the right equation, I will trust that you can solve it. Just set up the right equation here. Did you remember the divide by 12 in there? I know you didn't know the rate, so I know you probably put an R in there. But be careful. When they gave you the 2300, you'd have to put that here. And when they gave you the 6.5 years, it'd be really easy to put it right there and it would be wrong. Because you're doing your problem in months. So you can't use 6.5 years, you got to change that into months. 78, yep, 78 months. 6.5 times 12. That's an equation I could solve. You divide both sides by 1,000 first. Cut off a couple zeros. It's like 23 divided by 10, which is 2.3. 1 plus the rate divided by 12 to the 78th power. That's annoying. Then I guess I'd just use to the power of 1/78. And then I just have to subtract 1 and times by 12. Subtract 1 gets rid of that 1. And now it's R over 12. And then you'd multiply both sides by 12. Question about that? Which part didn't you get?
When you do multiplication.
So first we got to do this power. Do you agree with that?
Yeah, I did that
All right. What'd you get for that?
one. 1.01.
1.01. And then do you get why I'm subtracting 1 to get rid of this 1 plus right there?
Yeah.
Okay. So I'm subtracting 1. So now I got 0.01 equals R over 12.
Why don't you multiply first?
Multiply by what?
12.
Okay. I could have multiplied by 12 earlier in this problem, but I'm going to multiply it at the end. And it'll get rid of this 12. The divide by 12 and the times 12 will cancel. And if it times by 0.01, it moves the decimal over from the 12 over twice, and it's R equals 0.12. Who had 12%? Good. Okay. All right. I can tell these are not going to be the easiest thing, and it makes some sense because we're near the end of the chapter. This is where you have to like understand all of these things put together, plus you got to use your calculator to grind out some nasty numbers. All right. And there's still one more thing. I want you to look at this chart for a second. Hey, you guys signed up for honors. So I get to explain why E exists. You've seen E in some formulas, and it's going to be coming up a lot more in pre-calc. Do you get that this one is compounded once a year? Here it's twice a year. Here it's quarterly, 4 times a year. Here it's monthly. And when you just simplify this thing down, you start with 2, and then you get this number that's getting like 2, it's right around 2.7. And in fact, the more times you compound it, 52 times, which would be like once a week, 365, that's like once every day. What if you compounded once every hour, or once every minute, or once every second? Do you get all of these are getting pretty close to each other? In fact, it's zeroing in on this number right here. And that, my friends, is E. It's kind of like pi in that it's a number that goes on forever and never repeats. You are not going to be forced to prove that you know where it came from. But E is this number that if you compound, not just like every minute or every hour or every second, if you compound continuously, like all the time, because that's what happens in the real world. Okay, right now you have a bunch of little microbes in your gut. You all have guts. And they process your food when you eat it. And you got little microbes in there. There's way more of those little microbes in there than there are of you. They outnumber you, like 1,000,000,000 to 1. And they're very powerful. They actually have finding out things like the microbes in your gut control a lot. Like they can actually give you depression, the microbes in your gut. The microbes in your gut can make you extra hungry or not. They can make you the kind of person who just can't stop eating, and other people can. So it's a big deal. I think we're going to learn more about the microbes in your gut and how, like, hey, you just need a gut microbe transplant, and you're going to fix this problem that you have. It's true. There's actually a thing that does that right now, but it's too complicated for this lesson. My point, you're going to need to use continuous compounding to talk about those microbes in your gut, because do you think they all like wait to be like, they grow, right? There's more and more of them over time. Do you think they like all agree to wait till like every 1 minute and then they divide? No, they constantly are dividing. They're constantly multiplying in your guts. Okay, and you have stuff on your hands like right now on your skin. There's microbes all over you right now, and they're growing or shrinking. And if you just like spread some antimicrobial stuff on your hands, they're probably shrinking really fast. Otherwise, they could be growing. All right, so this is continuous compounding. That's what E does. All right, so when you see it in an equation like this, E, I want you to remember about 2.7-ish. But it's actually like 3.14 doesn't really tell you what pi is. 2.7 is close, but it's actually, it goes on forever and never repeats. It's 2.718, blah, 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 blah. Okay. Remember principle? You've heard that one before. So, what if we said, I'm going to give you $1,000 and let it continuously compound at 4%. Like it's just always growing at 4%. Not every hour, not every month, not every second. Always. Your $1,000 is always compounding by 0.04. But you're not going to let it do that forever, otherwise it would like take over the planet. And so then you got to put a time in there. And so let's say the time is like 38 minutes. And if the problem's in minutes, that's all you'd have to do. 1,000 times E, which is 2.7-ish, but it's on your calculator. It's got its own button on your calculator. From now on, you're supposed to use the button on your calculator every time you see E. So let's show you where it is. If you have the graphing calculator, I'd pull it up. I'm going to help you see where E is. Show you. See the divide key? Right above the divide key, that's where E lives. So this one, you'd go 1,000 times E, which is right above the divide key, to the power of, and I always put my powers in a parenthesis so that it doesn't screw up the order of operations, 0.04 times 38. That will tell me how many microbes I have running around on my hand. It started with 1,000. It's growing at 4%. I let it go for 38 minutes. Okay. PERT is the formula. See if you can tell why I called it that. PERT. Get it? We're not going to give you that on the test. You want to memorize that one. PERT. P times E to the RT. PERT. And PERT will work here. It'll help you memorize it. The amount is Bert, write it out. Stick the numbers in. This is the last problem. Today was a long day, but we're done. Just do this one problem with me. P is the principal, as in the starting amount, times E. It's about 2.7, but don't you dare use 2.7. It will screw up your answer. You've got to use the E that's above the divide key. To the R times T. I got the rate, but be careful. Did you get caught yet? For principal, it says the initial population is 250. Okay, that was easy. I was struggling to find the 250. There we go. P is 250. E to the rate. That's not a gotcha yet. The rate is given. It's just 4.6%. Careful, 0.046. But the next part is where they get you. Why can't I put 36 hours here?
Because it gives you the rate per day.
This was per day, and this was per hour, and they obviously are different. Since this one's in days, what is 36 hours? 1.5 days. Do you get now? I used the same units in both of them, and now I'll be okay. 250, here's exactly what you would type on your calculator, times E, which is the button above the divide key, to the power of, put a parenthesis to make sure it doesn't screw up the order of operations, times 1.5. There you go. Go ahead, type it in. I want to just see. Even with a class of really bright students, which you guys are, it's a good class. You guys average like an A- on most of your tests, which is really strong for a math class. A lot of people will have different answers on this because they'll screw up something. Let's see if you know how to type it in. Leo, what'd you get?
267.859.
Anybody verify 267.859? A lot of pans are going up. Awesome. If you're not getting that, you should probably check to see if you know how to do it on your calculator. All right, you made it to the end. So let's find that homework that's assigned for today. I'll tell you which ones to do and skip. I think it says right in the directions which ones to do, but I need to tell people at home. So I'll read it. You know what tomorrow is? It's the review. You know what the next day is? Test. And if up to here it was going fine, well, don't worry about it. There's probably only 1 or 2 questions on the whole test that are like today's homework. So the rest of the test is easier than today. Nice. All right. So on your homework, I'll tell you which ones to do and skip. You're going to do problems 1 through 4 and 6 and 8. Another way to say that is you should skip problem 5 and 7 and anything after number 8. Skip problem 5 and 7 and how much so far does it go after 8? Does it have anything after 8?
14.
Oh, you get to skip 9, 10, 11, 12, 13, and 14. All right, so you're doing problems 1 through 4 and 6 and 8. And that was a long lesson, and I appreciate you trying hard despite the room being extra warm today. Oh, and that was a long lesson. That's all I got for you.